right, practice exercise 79, some more algebra review, some order of operations. We had a problem or two like that last time. Also got scientific notation review. I'd encourage you to use that E notation just for the practice of it, and it's easier than writing times 10 and little exponents. And then the prime factoring, a little bit of prime factoring review as well. Exercise 79, go ahead and begin. Let's go ahead and take a look at these together. And Chris was first. Once again, the guys had a clean sweep of the top 3 spots. However, last time none of them got the candy. So, see if maybe today we'll get a guy to win the candy. Chris gets first crack at it. Going across the top row, what did you get for your answers?
5.
Good.
28.
Yep.
19.
Good. 5, 28, and 19, your answers. Next row.
8.
Yep.
5.
Yep.
5.
Good. 8, 5, and 5, your answers on the second row. The next row going across, how did you write 8,400?
8.4 times 10 to the third power.
Good. 8.4 times 10 cubed, or 8.4 E3. What about the next one?
3.4 times 10 to the negative second.
Good. 3.4 times 10 to the negative second power, or 3.4 E negative 2. How about the next one?
2.8 times 10 to the negative fourth.
Good. 2.8 E negative 4, or 2.8 times 10 to the negative fourth. And then the last one on that row?
1.25 times 10 to the fifth.
Good. 1.25 E5, or 1.25 times 10 to the fifth. All right, for the prime factors of 12.
3, 2, and 2.
3, 2, and 2, or 3 times 2 squared for 25.
5 and 5.
5 and 5, or 5 squared for 16.
2, 2, 2, 2, or 2 to the 4th.
Good. 2 times 2 times 2 times 2, or 2 to the 4th, and for 20.
5, 2, and 2, or 5 and 2 squared.
Good. 5, 2, and 2, or 5 and 2 squared. Batted down, rejected. Except you're supposed to catch it.
Sorry, Tom.
It's okay. You had that cornerback mindset instead of the wide receiver mindset there. All right. Hey, it's hard to make an elite corner stop defending passes. Or whatever we want to say. All right. Anyone else get them all correct, though not as fast as Chris? All right. Anyone just miss one? Any questions? All right. Pass those in if you would, please. And take out your notebooks. Turn to the transformations section. Turn to the transformations section. I want to check, make sure we got those transformations copied down last night. Transformations 1 through 5. So in the properties and transformations section, there will be 3 pieces of paper. The first one has all the properties. We already done those. Second page should be these 5 transformations copied out in a whole lot of words that's hard to understand. And then the third page is going to be those transformations that I was explaining kind of how it works so you could see visually how to make it work. Good. All right. There's that. Good. And then that page is going in. Good. Where's transformation 5?
There, you said 194 to 194.
24 to 196. Anyway, I'm not going to give you a homework offense, but make sure you copy it down maybe this evening because there's no other homework this evening. So go ahead and get a copy tonight. Just so we get that in there. Good. All right, that's what we're working at. There it is. That's what I was looking for. Excellent. All right, so let's go to review real quick, and then we'll get back to those transformations here in just a moment. Several things about our proportions. Obviously, how many terms are in a proportion, Audrey? 4, right? We've got 2 antecedents. We have 2 consequents because we're going to have 2 ratios, class, that are equal to each other, right? 2 ratios that are equal to each other. And we said that the first and the fourth terms, class, are called the extremes, and the second and third terms are called the means. And the fundamental property of proportions, class, states that
The product of the means equals the product of the extremes.
good, in any proportion, the product of the means equals the product of the extremes. And that's why, to solve a proportion, class, we will cross multiply. Which means that if any 3 terms of one proportion are equal to any 3 corresponding terms of another proportion, what else must be true, Kendall? Genesis? Ethan?
The 4 terms are equal.
The 4th terms, not necessarily the 4th, but whichever terms aren't mentioned, they have to be equal as well. For 3 terms of one proportion equal to 3 corresponding terms of another, the 4th terms would have to be equal. So again, just kind of put it up here so we can see it. If we had A is to G as X is to Z, and A is to G as R is to Z, what must be true? Back to Genesis.
That
Ooh, Kendall?
A, Z.
No, what must be true, Chris?
R equals X.
R has to equal X. Because these 3 terms and these 3 terms are all equal. So the 4 terms have to be equal. That's what must be true. We said this, that if the product of 2 quantities equals the product of 2 other quantities, then I could use either pair of values, Kendall, for redemption to be the means, and then the other pair of values would be the extremes in any proportion. So if you have product equals product, make 2 of them means, make the other 2 the extremes, or means and extremes. Doesn't really matter. And you'll get a true proportion every time. We said that if we wanted to find a mean proportional, and we're given 2 values, the mean proportional will always, Quentin, be equal to
Square root of the extremes.
the square root of the what of the extremes? The product. Good. The square root of the product of the extremes. We also said that if we had a couple of true proportions, you could take 2 true proportions and make another true proportion by doing what? Audrey? Chris?
Getting the sums of the extremes.
Not the sums.
The product.
The products of, not necessarily just the extremes, but the products of the, anyone? Corresponding terms. The products of the corresponding terms. So again, if we've got 1 is to 3 as 7 is to 21, and 5 is to 2 as 10 is to 4, what true proportion could we make from that? Back to Audrey.
5 is to 6 as 70 is to 84.
There we go. 5 is to 6 is 70 is to 84. And then we said that if we had a series of equal ratios, then we could take the, anyone? Sum of the antecedents and the sum of all the consequence, and that ratio would be equal to
The other three.
any one of the other ratios, because they're all equal anyway, so all of the other ratios. So again, if I had, 3 is to 4, as 15 is to 20, as 9 is to 12, I could make a new ratio equal to all of those. What new ratio might we make here, class?
27 over 36.
And there we go. Make sense? All right, so those are your properties that we need to have memorized, right? And I can tell some of you have varying degrees of memory on those. Now, yesterday we began looking at the transformations. You see them there in your notebook. You copied those out. Go ahead and read transformation 1 for us by way of refresher. Ethan, transformation 1.
If four quantities are in proportion, I can't read them right. They are in proportion by alternation. That is, the first term is to the third term as the second is to the fourth, or the fourth term is to the second term as third is to the fourth. Right.
All right, so basically if we have some proportion like 2 is to 5 as 4 is to 10, okay, true proportion. Alternation, basically, remember, is, what's that key word I told you to remember, class? Switch. You're going to switch the means with each other. So if I were to switch the means, what would my proportion look like, Kendall?
2 is to 4 as 5 is to 10.
There we go. I just switched the means with each other. I have another true proportion. Or we could switch not the means, class, but maybe the extremes. Jamie, what would that look like?
Extremes, would that be 10 is to 5 as 4 is to 2?
There we go. We're the two extreme switch places. Or we could switch both of them. What would that look like, Quentin?
10 is to 4, is 5 is to 2.
There we go. Where both of them means and extremes traded places. That was the alternation transformation. You're alternating. You're changing it out, swapping back and forth. The next transformation, transformation 2, Jamie, read that for us.
If four quantities are in proportion, they are in proportion by inversion. That is, the second term is to the first term as the fourth is to the third.
All right, and the key word I told you for inversion, class, was flip both. And that's important, because I don't have to switch both. I can switch either or both. But for inversion, I would have to flip both of them. What would this look like with the inversion transformation, Chris?
5 over 2 equals 10 over 4.
Good. 5 over 2 equals 10 over 4. We flipped both of them. Then we got to transformation 3, and there's a corollary for it. Audrey, go ahead and read transformation 3.
If 4 quantities are in proportion, they are in proportion by addition. That is, the sum of the first 2 terms is to the second term, as the sum of the last 2 terms is to the fourth term.
And then there's a corollary that goes with that, if you read that also.
If 4 quantities are in proportion, then they are in proportion by addition. That is, the sum of the first 2 terms is to the first term, as the sum of the last 2 terms is to the third term.
All right. So by the addition transformation, we said take a ratio and keep one of these the same, either antecedent or consequent. Ethan, pick one. 5. Okay, so we're going to leave the 5 where it is. But then we're going to add these two values to get 7. Well, in that case, we could do the same with the other ratio. Keep the 10 where it is, but then add the 2 values to get 14. And that would be a true proportion. Alternately, the corollary says what we could do is we could keep the antecedents instead. Maybe he goes antecedents, so we leave the 2 and the 4, and we still add to get 7 and 14. But either way, you still have a true proportion by what we call the addition transformation, because we're adding. Also called, what was the other name for it? Sounds cool, smart, musical. Composition transformation. Okay, the composition transformation. And that's where we left off yesterday. So if we switch the means or the extremes or both, class, this is called
Addition.
If we switch the means, or we switch the extremes, or we switch both of them, that's alternation. By the way, this is a skill to alternate that you're going to use a lot in physics your senior year. When we take these crazy equations and formulas to get things by themselves, alternation is a very valuable transformation. When we just flip both of them, we have the inversion transformation. And if we end up adding the antecedent consequent of each ratio together and then keeping either the original consequent or the original antecedent, that would be the addition or composition transformation. Addition's easier to write. All right, transformation 4, you have it on your paper there, so let's go ahead and read it and then we'll put it on the explanation page. Genesis, transformation 4, and the corollary, if you read both of them.
If four quantities are in proportion, then they are in proportion by subtraction. That is, the difference of the first two terms is to the second term as the difference of the last terms is to the fourth term.
And then the corollary?
If four quantities are in proportion, then they are in proportion by subtraction. That is, the difference of the first two terms is to the first term as the difference of the last two terms is to the third term.
All right, so go to your explanation page now, transformation 4. And we're going to call this the subtraction or the decomposition transformation. The subtraction or the decomposition transformation. Obviously, this is going to involve subtracting quantities. Now, yesterday we kept working with pretty much the same proportion every time. Was it 2 is to 3 as 4 is to 6 yesterday? Okay, let's go and roll with that. 2 is to 3 as 4 is to 6. So we start with this. We can go 2 different directions with this. Just like the addition transformation, you can keep your original antecedents or you can keep your original consequence. We're going to let Jamie decide.
Keep the antecedents.
We're going to keep the antecedents 2 and 4. But we're going to subtract these two values. We would subtract 2 and 3 class to get 1. Or negative 1, but presumably 1, because we don't like negatives. So since we subtract 3 minus 2 to get 1, we subtract 6 minus 4 to get 2. And notice it still is a true proportion. Or, JV could have picked, instead of the original antecedents class, we could have kept the original consequence, 3 and 6. But when we subtract, we still will get 1 and 2, and another true proportion. So subtracting, keeping one set of original, either both original antecedents or both original consequence, and then do the subtraction or the decomposition. Questions on this transformation? All right, just like addition, only you subtract. Transformation 5. Go ahead and read that for us if you would. Kendall, nice and loud.
If four quantities are in proportion, then like powers or like roots of these quantities are in proportion.
All right, like powers or like roots are in proportion. I call this the power root transformation. It's on your explanation page now. Transformation 5, the power root transformation. I'm going to do this 2 different ways. I'm going to start with powers, and we're going to start with that same 2 is to 3 is 4 is to 6. As long as every single term gets raised to the same power, we have a true proportion. Now, the easiest power to raise to, besides the 0 power, or the first power, would be the second power, right? We need to square everything. Well, if we square everything, what does our proportion look like now, Kendall?
4 is to 9, 16 is to 36.
And sure enough, you cross multiply, you get 144 both ways. It's a true proportion. I suppose maybe we could even cube everything. If we cube everything, do it with me, class, we would get 8 is to 27 as 4 cubed. 64 is to 6 cubed. Testing your memory here. 216. And I need to brush up on our squares and cubes and stuff here. You could work for any power. You could do like 8th powers if you wanted to. I'm not a glutton for punishment. I'm not going to do 8th powers. But you could, right? As long as everything's raised to the same power, you cross multiply. And in both cases, getting, oh goodness, what is that? 1,728, I think is what that is. So I'm big numbers. But today, cross multiply, it still checks out. As long as everything's raised to the same power. Alternately, we could take the same root of everything. So for instance, if we had something like oh goodness, 25 is to 36 as 100 is to 144. Somebody in your calculator real quick. Let's make sure that's a true proportion before we actually roll it. What's 25 times 144? I knew the other in my head, but 25 times 144? Call it out.
3,600.
Okay, good. This is a true proportion, right? 3,600. Okay, both ways. All right. In that case, as long as I take the same root of everything, it'll be a true proportion. So obviously, the easiest root to take of these numbers would be the square root, right? They were all set up purposely to take the square root. When I take the square roots, I get 5 is to 6 as 10 is to 12. And is that a true proportion? Yes, you could cross multiply, make sure you got 60, or you just rotate the 5 to 2's out, you back to 5 to 6, or multiply 2's to get the 10 to 12. Questions on the power root transformation? All right, questions at all on these transformations? Look at your textbooks then, page 196, and you can go ahead and set your notebooks aside. Maybe just have some scratch paper out. Or if you want to keep your notebooks out, maybe class notes section. It doesn't have to go in your notebooks though, just doing some extra practice here. Part of the value of transformations, again, the idea behind a transformation is changing the way something looks without changing what that thing is in its very essence, right? We talked about, the transformer car robot thing, right? It's a robot, it's a car. Same pieces, you don't take pieces off, but you transform its look and its function, apparently. The Bible says that we are transformed, right? We're still, before he got saved, he was Quentin, right? After he gets saved, he's still Quentin, but there's a different outward bearing about him, right? There's a joy about him, a peace about him. Some people, for instance, got the drunk on the street, gets gloriously saved. He's still the same person, but outwardly there's a change, right? That's what should happen when we get saved, that transformation. The idea here that is we can take a proportion, and if we don't like the way it looks, using one of these transformations, we can change the way it looks. And the best value here would be in moving what you want around. Look at number 1. It says, by successive transformations of the proportion A is to B as C is to X, write the proportion in which X occurs as the third, second, and first terms, respectively. I don't like the X in that bottom spot, that fourth spot. I want the X in the third spot. Question, think about it and raise your hand when you've got it. What transformation would allow the X to go from here to this third spot? What transformation would allow the X to move from the fourth spot to the third spot? Chris?
Flip transformation?
Well, we call it the, you're right, it's the flip transformation. What's the technical term for it? Ethan?
Alternation.
No.
Inversion.
Inversion transformation. But the key is, remember, you said flip. We have to remember to flip both. So what would it look like if I flipped both?
BA equals...
B is to A.
B is to A as X is to C.
Good. B is to A as X is to C. And so now, if I didn't like it in the fourth spot, fine, put it in the third spot. What if I'm like, no, I don't like it in the third spot either. I want to put it in the second spot. This kind of sounds like a lady looking at her living room and rearranging the furniture. No, I don't like it right there. Let's try it over there. And the long-suffering husband's just like, okay, dear, I'll just keep moving this piano everywhere. Anyway, I'm not picking on my wife because she only had to move the piano once, and it was only like 3 feet down the wall. So, but it was for a good cause. Anyway, she wasn't all over the room though, so we're good. But what if I wanted it I want it right here. I want it in the second spot. What transformation would allow me to put the X in the second spot? Someone besides Chris, he helped me last time. What transformation, Jamie?
The alternation
Okay, alternation. What would it look like if I alternated?
would be B is to X as A is to C.
There we go. Now, we could, I suppose, flip the extremes as well, but there's no need to. All I want to do is put the X here so the A trades with it. Notice, the A and the X continue to stay together, don't they? And then what if we're like, no, I really, really like the X in the first spot. Like, that just makes the most sense to me. So I've seen it everywhere else. No, I really mean it. I really mean it, Jerry. I really want it over there. We really want the X in that first spot. Ethan, what would we need to do?
Inversion.
Another inversion to get?
X is B as C is the A.
There we go. We flip them both. And again, do you see how you can put the X anywhere you want it? It's up to you how to get it by itself. The various transformations can be helpful there. Look at number 2. Read that for us if you would, Genesis.
Write x is to AB. Write x equals AB is to C. So
AB over C.
AB over C. So that x occurs as the fourth term of the corresponding proportion as the third term of the proportion.
All right, so they give us something that is not a proportion. Agreed? This is a weird thing. Okay? They're telling us x equals this quantity, AB over C. Whatever A is, multiply by whatever B is, and divide by whatever C is. They say, let's take this and let's make it a proportion. Well, if I want it to be a proportion, let's first of all, we have a property, remember, that we used, where we said if we have this situation, we can make a proportion. Do you remember what that situation was? If we had, Chris?
I was going to say, can we just put a 1 under the x, but we can't do that.
Okay, we actually kind of could, I suppose.
That's not what you were shooting for, though?
It wasn't what I was shooting for, but it could work. It's another pathway there. So there's 2 ways we could have gone. That's one way of them. All right, now we've kind of got a proportion, but it still looks kind of funny because I've got like an x by itself, a c by itself, and then kind of an ab together. Any thoughts on how we could, yeah?
Can you move the a under the x?
Oh, do you see the AB is still together, but it's now written like a proportion? This is one approach to it. The way I was going to suggest was, I don't like fractions anyway. So another thing was, well, what if we multiplied everything by C? Then it would have gotten CX. Here the C's would have canceled. It would have gotten AB. And now, if the product of 2 quantities equals the product of 2 other quantities, you can make a proportion out of it, right? Either way would have worked. This was not, to me, the most intuitive way, but it's actually the way I would have done it. So Chris is thinking on my wavelength. I don't know if that scares him or not.
Modern
But yeah,
minds think alike.
x over a equals b over c. But it wants the x in the 4th term, as the 4th proportional. So if x is going to be the 4th proportional, how do I go from what Chris has to putting the x down in this spot? What would I need to do, Kendall?
Inversion.
Well, if I flip it, the x doesn't come in the 4th spot. It would actually go in the 2nd spot. I want the x in the 4th spot.
Alternation.
Okay, alternation, what would that look like?
B is to C.
All right, what is alternation?
Flipping.
Not flipping. What's the word, class? Switching. Okay, yes, you got it. Switching just the means or just the extremes, or you could switch both. Is there any reason to switch the 2 means with each other? But I really want to switch the extremes, don't I? So let's just switch the extremes.
C is to B.
You could. I was going to leave the A and B where they were. Right? And then we would just switch those 2 with each other. You could switch both, though. It would not be wrong, Kendall, for you to put the B here and the A here. That would work as well. Okay? The important thing was, though, we got the X in the 4th spot. Now, what if I wanted the X in the 3rd spot? Genesis?
Inversion.
That would be inversion. What would it look like?
You want the x in the 4th.
I want the X in the 3rd spot, so I want the X here.
B is to C is x is to A.
There we go, just flip them both. B is to C is X is to A. So again, the idea here is you can take something that isn't even a proportion. It's just some funny looking whatever. You can make it a proportion. And then once you've got something in a proportion format, there's a whole bunch of stuff you can do with it. So again, proportions very helpful in getting things the way we want them. Let's drop down to number 4 and we'll do part A. Go ahead and read that through part A for us if you would, Ethan.
Test the validity of transformations by alternation, by inversion, and by addition and subtraction by transforming each of the following proportions. 12 is to 8 as 9 is to 6.
All right, so we're just going to do this one for sake of time. 12 is to 8 as 9 is to 6. First of all, before we start transforming anything, we want to make sure this really is a proportion, because the book might be testing us here. Is this a true proportion? How do we know? Because if it's a proportion class, the product of the means equals the product of the extremes. What's the product of the means? 72. What's the product of the extremes? Okay, so this is a true proportion, right? At your seats, there are 3 different ways you could do it. I want you to do an alternation. I want you to do an alternation transformation. There's 3 different ways you could do it. Just do one of them. And let's start with Chris. What did you do?
I put 6 is to 9 as 8 is to 12.
All right, so he took the extremes, switched them, and he took the means and switched them. Anyone do it a different way than Chris did? Have something other than what Chris had. Jamie, what do you have?
I have 6 is to 8 as 9 is to 12.
All right, so you just switched the extremes, okay? Anyone just switched the means? Okay, Audrey, you did. What did you have?
12 is to 9 as 8 is to 6.
There we go. These are 3 different ways, and they're all correct. Any of them would work. All right, all of these correct ways. How many had one of those 3? All right, excellent. All right, now let's take the same yellow proportion, transform it by the inversion transformation. There's only one way that you can do this. There's only one way that you can do this one. And let's see if Quentin got the one way.
8 is 12, as 6 is 9.
And excellent job there. How many had the same thing Quentin had on the inversion transformation? Again, flip both ratios. All right, how about the addition or composition transformation? There's a few different ways technically you could do this one. The addition transformation. Kendall, what did you write?
12 is to 20 and 9 is to 15.
All right, so Kendall kept her original antecedents, but then she added the terms to create new consequence, but it is still true. 180 equals 180. Good job. Anyone have the same thing Kendall had, first of all? How many had something different than what Kendall had? All right. Ethan, what did you have?
1 is to 8 is 15 is to 6.
All right, you added them and you kept the original consequence. And that would be correct. You said 15 is to 6. I'm looking over there for the 8 and I just kept copying. 20 is to 8 is 15 is to 6. How many had that one? All right, now technically, if you said 8 is to 20 as 6 is to 15, this wouldn't actually be wrong. You keep the original consequence, but you put them up in the antecedent for no good reason, and then you add and make new consequence out of them. The book actually even discusses that. Really, you realize all you did is what Ethan did, and then invert?
Why?
Right? Why? I don't know. These are, to me, the main 2. The other ways you could have said, well, technically, you could say, well, let's keep these but move them down and make 12 and 9 the original consequence, the new consequence, and then we'll add them to get the 20 and the 15 there. Again, that's just the inversion of this one. So to me, these are the most straightforward 2. But you could do almost successive transformations in that case. I wouldn't. But those were the answers I was looking for. Were the 2 in the circle? Yes, sir.
Can you add 6 to 12 and then add the 8 to the 9?
No. Well, let me just show it. Like if you did 18 is to 8 and then you added 18 and you get 17 is to 6, is that a true proportion? No. So no, it would have to be within the same ratio. Okay, good question. All right, subtraction transformation. Or decomposition transformation. Let's see, how many musicians in here play instruments? Just a couple of you. Okay, so y'all know the joke about like they're walking through the cemetery where some of the great musicians are buried and they're like, what is that sound? So they dig up Beethoven's casket and they're like, he's in there erasing a whole bunch of sheet music. What are you doing? I'm decomposing. Anyway, that's a dumb music joke, but anyway, that didn't stop me from saying it. I did, however, while I was thinking of it, I managed to erase the original proportion, which was 12 is to 8 as 9 is to 6. All right, so for your subtraction transformation, how did you set it up? Chris, how was yours?
I did 4 is to 8 as 3 is to 6.
Good, 4 is to 8 as 3 is to 6. Works great. And another way we could have done it, Quentin? That's how you did it as well?
Yeah.
All right, anyone do it a different way? Everybody did the same way as Chris? How many had the same way as Chris? All right, you had something different. Jamie?
I was getting confused I was doing like 10 is to 8 as 7 is to 6, but that won't work.
10 is to 8 as 7 is to 6. I'm curious where the 7 and the... Okay, so the idea here is what Chris did, what a lot of people did, is they kept the consequence the same, and you subtracted to get the new antecedents. We could have, class, kept the same antecedents. You could have kept the 9 and the 12, or the 12 and the 9, and then subtracted to get, class, and -4 and -3. Though if you had both negatives, they would have canceled anyway to get 12 is to 4 as 9 is to 3. But it wouldn't technically be even wrong with the negatives, right? Because you cross multiply, you still get -36, right? Product of the means still equals the product of the extremes, which means it's still correct. Okay? Good. Questions on that? The text doesn't ask for this one, but I want you to do the power transformation on this. The power transformation on this one.
You must hate us.
I would recommend doing squares, because then, like, a 5th grader could do it. Like a show, are you smarter than a 5th grader?
No, I'm not.
Quentin's like, nah,
Some
I'm not.
of those
That show makes
some of
me
those
doubt
questions
it,
are hard.
Some of those questions.
Like, I don't know where Napoleon was born.
Wasn't he born in France? I mean, he was the French leader, so I'm assuming
And
France.
so one would also assume that Hitler was born in Germany.
But Hitler was Austrian. He wasn't even German.
Yeah.
So I don't know what his...
Probably was Portuguese.
No, he was Austrian. All right, so what did you get for this one, Kendall?
144 over 64 is to 81 46.
All right, so let's try saying that again. 144 is to 64 as 81 is to 36. And you can check the cross multiplication there and make sure it checks out if you want. But it does. She squared everything correctly. Questions on these transformations?
Easy.
Easy? Good. I like that you say it's easy. So let's do this now. Let's try putting it in reverse. I'm going to do a transformation. And let's see if you can tell which one I did.
Just Ethan or all of us?
Oh. All right, so let's start me off with a true proportion here. Audrey, make up a proportion for us. Don't make it too hard now.
6
Just make up a number for this.
is to 3.
3, okay. As.
4 is to 2.
Very good. See? All right. Give her a hand. Give her a hand. Put her on the spot. She's going to win the proportion. Good. Hey, you have the makings of a math teacher, Audrey, because that's what a math teacher does, is make up problems off the top of his head. You did a good job.
What?
All right, so you tell me what transformation I am doing here.
The whole class or someone?
Everybody, what do we got, class?
Inversion. Nope, you have alternation.
Alternation. I took the 2 and the 6 she gave me and I switched places with them. That's just an alternation. How about this one?
Addition.
Yeah, the addition. I added to get the 9 and the 6, and then I left the 3 and the 2. Let's see. So, Chris, you answered this last one. Who answered the first one? Who said alternation? Okay, so you two sit out for this next one. If I've got... well, that's going to make life hard. Let's change your proportion a little bit here, Audrey. No offense. Only because since it's a half relationship, I can't really do a subtraction transformation well. So I haven't really thought of that. Let's do 5 is to 3 as 10 is to 6. How about that? So we've changed it.
So we're back in?
Everybody back in. All right, so let's do 5 is to 10 as 3 is to 6. Which would this be?
Both alternation.
That'd be alternation again.
Do I have to draw one
How about this one? 3 is to 5, yeah, as 6 is to 10. Look at the inversion transformation. How about this one here? Let's do 5 is to 8 as 10 is to 16. Addition. I added. How about 25 is to 9 as 100 is to 36?
Some roots and squares.
The power root transformation. Those powers in this case. How about 5 is to 2 as 10 is to 4? Subtraction transformation. How about 6 is to 10 as 3 is to 5? Alternation transformation, but I switched both of them this time. Both the means and extremes got switched into places. How about 2 is to 3 is 4 is to 6? Subtraction, transformation.
Get back in.
Right? Sure. Questions on transformations? Questions on these? All right. Go ahead and clear your desk, except for a clean sheet of paper.
I knew it.
And a pencil. You don't really need a calculator. Sheet of paper, pencil. Don't need a calculator.
This is pretty hard.
Everything else will work. Well, Ethan's going to fail. The rest of y'all feel pretty good, though, so I'm going to give the quiz because y'all are ready for it except him. So.
Okay. Wait, I'm ready. Can I choose not to take it?
Sheet of paper, pencil, all you need out. Don't need a calculator for this. First last name at the top of your paper along with today's date, which is 3/3/21. First and last name, 3/3/21. Today's date. There will be no homework this evening, so the video will end once I've gone over the quiz with you.
Which quiz is this?
There's quiz 32B. Quiz 32B, or not to be. Quiz 32B. Let's take a look at the quiz together very quickly. Numbers 1 through 6. True or false? If I am telling the truth in that statement, then write true. If I am lying, write false. And for number 7 through 10, for each of those, take that given transformation and make a new one. Make a new proportion by performing each transformation. In many cases, there's more than one way to do it. I only need you to do one. You don't get extra points for doing more than one. So just give me one for each of them. And if you know more than one, give me the one you're more confident in. All right, so that's pretty much it. 6 true-false questions, 4 transformations to do. You may begin.